In this video, we will discuss several of the units which we'll use in the study of electricity. The first is the unit of electrical charge, the coulomb. It is named in honor of Charles de Coulomb, a French physicist who lived from 1736 to 1806. He experimented with the attractive and repulsive forces associated with electrostatic charges and devised a sensitive torsion balance to accurately measure these forces. The results of these experiments led to his development of what is now referred to as Coulomb's law. This states that the electrostatic force exerted between two charged bodies is proportional to the product of the two charges and inversely proportional to the square of the distance between the charges. The modern mathematical expression for this law is F equals K Q1 Q2 divided by D squared. Where F is the force between the two charges measured in newtons, K is a proportionality constant, Q1 and Q2 are the electrostatic charges measured in coulombs, and D is the distance between the charges measured in meters. A coulomb of electric charge is made up of 6.24 times 10 to the 18th electrons. That is a huge number. In fact, it is 6.24 quintillion electrons. We could never experience an electrostatic charge of a full coulomb. The forces it would generate would be tremendous. At most, we might experience a trillionth of a coulomb of static charge. For example, when we comb our hair on a dry winter's day, the comb might have an excess of a few million electrons. However, when an incandescent light bulb is illuminated, the total amount of electric charge which passes through the filament will be about 1 coulomb each second. The next unit of electricity is the volt. It is named in honor of the Italian physicist and pioneer of electricity, Alessandro Volta, who lived from 1745 to 1827. He constructed what was to be the first battery called the voltaic pile. This consisted of a stack of discs of zinc and copper alternately spaced with paper soaked in salty water. When a wire was attached to the top and bottom discs, an electrical current was continuously available. The electromotive force between the top and bottom discs is measured in volts, and this is often described as being a measure of electrical pressure. But a more rigorous definition of the volt is in terms of energy per charge. Specifically, 1 volt is defined as 1 joule per coulomb, so V equals E over Q. The next unit is the measurement of electric current, the ampere. It is named in honor of André-Marie Ampère, a French physicist and mathematician who lived from 1775 to 1836. His chief work in electricity was formulating the laws of electromagnetism, which we will study later. For now, it is important that we understand the electrical unit which bears his name, the ampere. Specifically, 1 ampere is equivalent to 1 coulomb passing by a point in a circuit each second. The symbol for current is the letter I, and its units are amperes. Hence, I equals Q over T. The last unit we will take a look at in this video is the unit for resistance. This is named after George Ohm, a German mathematics teacher who lived from 1789 to 1854. After 1820, he began doing experiments in electricity and discovered that increasing the length of a wire resulted in a decrease of current flow through the wire. These experiments resulted in the formulation of what is now called Ohm's law, which can be written as I equals V over R, where the current is equal to the voltage applied divided by the resistance in ohms. When current flows through a resistor, energy is dissipated in the form of heat, and a voltage drop occurs across the resistor. The difference in potential across the resistor is determined by Ohm's law. The final slide in this video asks several questions about the units of electricity. Try to answer the questions and review the video if necessary.